The requirements imposed on protection departments within transmission and generation utilities are increasing as regulators seek to ensure protection systems prevent catastrophic outages and abate cascading events. Protection compliance assessments review the performance of relay elements along several dimensions, to ensure dependability and security are maintained. These dimensions include transmission line and generator loading levels, and the load demands arising from system power swings. They also consider the coordination of generator protection and control elements with unit capabilities, and the setting of frequency and voltage elements to ensure system operation remains within required bandwidths. With the variability that exists in today's generating schedules, the performance of load-responsive protection elements must be reviewed to ensure they accommodate the loadability of transmission lines and generating systems. Transmission line loading reviews identify phase distance and overcurrent elements, including switch-on to fault, and assess their ability to tolerate emergency or contingency load currents coincident with lower relay bus voltage levels. Load-responsive protection elements in generator protection schemes are required to keep the units in service under stressed load conditions. The locations of these load-responsive elements within a generating system, and their protection types, are used to determine suitable loading criteria to test the element's performance. Realistic overload scenarios are derived from power flow calculations, based on the generator's real and reactive power, voltage levels at step-up transformers, and the plant's internal impedances. With the increased penetration of inverter-based generating systems, it is no longer adequate to simply investigate protection performance under steady-state loading conditions. These static sources have caused changes to the speed of system power swings and the location of their electrical centers. The performance of overcurrent and impedance-based protection under stable power swing conditions is reviewed to ensure these load-responsive protective relays will not trip when subjected to these disturbances. A power swing stability boundary is established for each impedance-based protective element. The boundary is derived from the system and generator impedances and voltages, determined from the relay location and network parameters. The currents and voltages at points on the boundary are supplied to the distance element to determine if it intrudes on the protection characteristic, leading to a potential compromise of its behavior during stable power swings. For the analysis of the performance of phase overcurrent protection elements, the relay's response is determined by comparing the pickup settings with the maximum currents that can present during the disturbance events. It is important to ensure proper coordination between protection elements and generating unit capabilities and excitation controls is achieved. Studies investigate the margins between loss of field elements and generator capability curves, and their under-excitation limits. In addition, volts per hertz elements are assessed against the overfluxing capabilities of generators, and the short-time thermal capabilities of units against over-excitation limiters. To complete the suite of assessments, the operations of voltage and frequency elements are compared against system operating bandwidths, to identify if the protection functions fail to prevent excursions outside these upper and lower limits. The comprehensive assessments performed by protection compliance reviews ensure protection systems keep pace with the changes in the nature and behavior of modern power networks, and the goals of dependability and system security are maintained.